In lesson 7.2, we're going to be learning another method for solving systems, and it's called substitution. So looking at your first example in your notes where it says y equals 6x and 2x plus 3y equals negative 20. Last week we learned how to solve a system with graphing, but if we didn't want a graph or we didn't have an easy way to make the graph, here's another possibility. So what we're going to do is we're always going to look for a variable that's by itself. So what I mean is like this y is on one side of the equal sign by itself. And we're going to take what it's equal to. It says that y is equal to 6x, and we're going to substitute that into the other equation, and we're going to put it in place of the y. So since 6x is equal to y, it should be able to take the place of the y. The y won't be there anymore. So now I'm going to write that equation. It will say 2x plus 3, but when I get to where the y used to be, I'm substituting in the 6x. And then it still says equals negative 20. Now this is a better equation, even though it looks a little more complicated, because it only has x's in it, which means we can solve it. So I'll have 2x, and now I'm going to do this. 3 times 6x is 18x equals negative 20. I'll put together the like terms that are on this side of the equation and have 20x equals negative 20. And then if I divide both sides by 20, I'll figure out that x is negative 1. So now I have half of my answer. And remember how we're looking for a pair of numbers that works in both equations, and they go x, y. So now we know x is negative 1. So if I go back to the beginning of the problem and put a negative 1 right here, this equation tells me y is equal to 6 times negative 1, so that would be negative 6. And that's the point that will work in both equations. Okay, let's try the second one. So the second problem that you have is x is equal to 4y plus 7 and 2x minus 6y equals 12. All right, so again, I'm going to look for a variable that's by itself. In this case, it's the x. I'm going to take what it's equal to and push it into the other equation and substitute it in place of the x. And this time I'm putting it in place of x because it says 4y plus 7 equals x, so it takes the place of x. And now I'll rewrite this equation, and it'll say 2, but instead of putting in x, I'm substituting in 4y plus 7. And then the equation still says minus 6y equals 12. And now I'm going to solve this equation, so I'll have to distribute first. I'll get 8y plus 14 minus 6y equals 12. And then I'm going to put together these like terms. Since this 8y and minus 6y are on the same side of the equation, same side of the equals, they go together, and then I'll have 2y plus 14 equals 12. And now I'll subtract 14 from both sides to get 2y equals negative 2. And divide by 2 to get y equals negative 1. So this time in my answer, I want to be careful to put the negative 1 in the place of y. And then to figure out what x is, I'll go back to the beginning. And if I put the negative 1 right here, this equation says x is equal to 4 times negative 1, that's negative 4, plus 7 will give me a 3. So I'll get 3 for the second number. Now, in your notes, your number 3, we're going to not do that one today. I'm going to put in one that's almost easier, but then because it's easier, it kind of makes it harder. So I'm going to say 2x plus y equals 16. And then I'm going to say y equals negative 10. So at the beginning of your assignment today, you'll get something like this. And it confused people because it's actually a little easier, but the steps might seem a little different because you already know one of the answers. We already know that y is negative 10, so we can just put that in place right away. But then we're still going to find a variable that's by itself, take what it's equal to, and substitute it into this equation. And so it's going to take the place of the y. And now the top equation would say 2x, but instead of a y, I'm substituting in a negative 10 equals 16. And I'll just finish solving this. I'm going to add 10 to both sides, and I'll get 2x equals 26. If I divide both sides by 2, I'll now know that x is 13. So in a couple problems at the beginning of today's assignment, you'll be given one of the variables, and then you just have to find the second variable. And then I also wanted to look at a problem, a different word problem than the one in your notes. Maybe you can find a little room on the blank page. Like if you page back in your notes a couple pages, you had a blank page. So we're going to say that Justin makes, that he gets a new job and he makes $15 an hour. And he's going to get a raise of $3 an hour every year. Okay, and then I'm going to say that someone else, let's say Cameron, he makes not as much. So he only makes $12 an hour. But he gets a raise of $5 an hour every year. So even though he doesn't make as much, he gets bigger raises. Okay, so I'm going to write an equation for each of these guys. So here's Justin. So his equation would say he starts with $15 and he makes an extra $3 every year. So we'd add 3x. And then here's Cameron's equation. He makes $12, but then his raise is $5 an hour. And now the question would be, when would they make the same amount of money? So what I'm going to do to solve the system, I just want to know when they make the same amount. So I'm going to take this y that's by itself, take what it's equal to, and substitute it in that place of y. It takes the place of y. So I want to know, when does $15 plus $3 an hour equal $2 plus $5 an hour? So I'm going to solve this. Okay, so the first thing I need to do this time is get all the x's on the same side. So I'm going to take 3 x's off of both sides, and we'll have 15 equals 12 plus 2x. And now I'm trying to solve it for x, so I'll subtract 12, and I'll have 3 equals 2x, and divide by 2, and I get x equals 1.5. So in my pair, x would be 1.5. And then I'm going to go back to this original equation up here, way back up here, and put the 1.5 in place of x. So I'll be doing 15 plus 3 times 1.5. And that's 15 plus 4.5. So that would be 19.5. That's going to be the y. Okay, this is how many years it will take, 1.5 years, until they make the same amount. And this is the number of dollars per hour. Okay, then we're just going to do this last one. That's number 4 in your packet. And we skipped or changed number 3 or we're saving that one for tomorrow. Okay, so here we have number 4. It's kind of like the one we just did. So we have y equals 45 plus 30x. But then we also know that y has to equal 80 plus 25x. So what we'll do is look for a variable that's by itself. I'm just going to pick the bottom one this time. It doesn't matter if it's on the top or the bottom. I'm going to take what it's equal to and push that into the other equation, and it will take the place of y. So we'll have 80 plus 25x equals 45 plus 30x, and that's what we need to solve. I'm going to subtract 25 x's from each side. So I'll have 80 equals 45 plus 5x. Subtract 45 from each side, and I'll get 35 equals 5x. Divide by 5, and I'll get x equals 7. So then the first part of my answer will be x equals 7. I'm going to put the 7 right here. And now I would have 80 plus 25 times 7. So we'll have 80 plus 175. And then that would be 255 for y. Those examples should be matched up with the examples in the assignment today for 7.2a.